Good morning, everybody. Thank you for attending this month's webinar. The October installment is scripting in CST. I'll keep my preamble to a minimum. CST's outside my knowledge, so I don't have much contributing here. But William is very knowledgeable, so I'm sure we'll all learn a lot. And I've had a sneak preview at the content, and he's got an end-to-end demo that he's going to walk through. So get your notepads and pens out. There's certainly going to be something for everybody. Even if you don't want to automate the whole process, he'll run through each individual aspect. So there's certainly going to be something useful for everybody. I'll hand over to William in a minute. Just a reminder on the format. If you have any questions, then please ask them in the question box. We're not going to go through those live. What I do is I collect all the questions, hand them to William. He will address the questions at the end of the slides, and then when you get the slide deck next week, any questions you've answered will be at the end of there. That gives William more time to answer the questions more comprehensively, maybe send up links or diagrams to explain his points further, and it means that everybody gets to see the answers. So yes, either use the question function, or on the very last slide when we get to the end, it will have William's email address and my email address, so you can email us directly with some questions as well. So that's everything from me. Oh, I've lost my mouse. 1 second. Get rid of my face. Right, and I'll now hand over to
Hello everyone, and welcome to today's webinar, which will be about scripting in CST Studio Suite, and more specifically about scripting using the Python interface, which is one of the more recent additions to CST. So my name is William Nyrén, and I work as a simulation engineer here at TECHNIA and provide support and training to CST users. And I've been here at this position for just over a year now. And from my master's degree in engineering physics and my work here at TECHNIA, I have over 5 years of scripting experience. In today's webinar, I will start with an overview of the CST Python interface. Then I will get into the different options you have to use Python with CST. Then I will show you how to get started with using the Python interface. And after that, we'll go through a little bit about the documentation, since I find it useful and important to find the relevant documentation efficiently, especially when working with a new API. Then I will go through a little bit about workflow and workflow using the history list, which you might be familiar with from within CST. And then I will show you a live example where I will be using the Python interface to set up a simulation project and then access and export results from the simulation project. Here we have an overview of the Python interface, and when installing CST 2025, you will also get a pre-installed or bundled Python interpreter with the installation. And this interpreter is based on the Python version 3.9. And also with this bundled Python interpreter, you also get some pre-installed third-party packages, such as NumPy for numerical and math operations, and H5Py, for example, to read exported electric field data from CST, and then matplotlib to create plots. And then there are also other packages as well, such as SciPy, for example. And with the installation, you also get a will package of the CST Python API, and this allows you to install the CST Python API to your own custom Python installation. And this will package supports Python version 3.8 up to 3.12. Then also new for CST 2025 is that you get a set of Python tutorials inside of the documentation that comes with CST, also known as online help. And if you are using the 2025 version of CST but not able to find these tutorials, I will recommend you to update to the latest service pack, and then the tutorials will be accessible to you. And with the Python interface, you will have automation capabilities such as controlling the software, automate modeling, setup and run simulations, and also access and process results. You have two options to use the Python interface with CST. The first option is to use run script from inside of CST, the CST frontend, by navigating to the Home tab and then use the Python menu as seen here to the far right. And from this menu, we'll be able to access and run your scripts by expanding run script. And here we'll be able to and here you have the ability to control the accessibility of your Python projects or in Python scripts. So for instance, if you have a script or a folder that contains multiple Python files and scripts, you can decide which one should be accessible from the CST frontend. This helped you to keep the Python menu clean and only use the script that is intended to be as the main script. Then you are also able to use the Python interface by simply running your code as any Python script using, for instance, a command prompt or an IDE to access the Python interpreter. Then you're also able to, for instance, use a Jupyter notebook as well, which is my preferred way when working and developing new scripts, since I'm then able to test my code quickly and also see the immediate effects inside of CST. So I know that my script is working as intended. And getting started with the Python interface is simple. To run your scripts from the CST frontend, you simply place your Python file inside of one of the library paths you have listed inside of CST. Then you go to the Python menu and click on Update menu to make your scripts appear under Run Script. So in this example to the right, we can see that I created a Python file inside of one of the default library paths, but of course you can also add your own library paths instead and use that by simply go to Manage Libraries inside of the CST frontend. Then when it comes to using a custom Python interpreter, you simply install the Python version that you would like to use. Then you use the pip package manager to install the included wheel package, and then to find the command that you would use, you can go to online help, and there are also other details in the documentation. And now a few words about the documentation of the Python API. So with the API, you will have access to lots of methods, and to find them, you can query methods using Python directly, or you can navigate through the online help and documentation. And when doing so, you will see that you have separate sections for Visual Basic and Python under Automation and Scripting, as seen here to the right. And it is the case that you will find documentation that is relevant to Python methods inside of the Visual Basic section, since a lot of methods and objects can be used with either Python or VBA, so they also have a common place for the documentation. And if you'd like to see more about this in more detail, I recommend this knowledge base article that you see here on screen, and you can find it by simply search for the QA number in the knowledge base. And in this webinar, I will be focusing on the CST.interface module, and then later on in my example, I will also be using the CST results module. But as you can see, we also have other modules available, for instance, the EDA module to work with PCBs. And the interface module is the one you would use to be able to control a running CST instance. And from this module, you're able to use the project class and the design environment class. And the design environment class is essentially the root to everything. And with this design environment class, you are able to connect your Python script with the CST frontend. With the class, you are also able to use command line options to, for instance, launch simulations in batch mode, which means that you are able to run simulations without using a front-end license. Then you're also able to send jobs to a solver server if you have that set up. Then you're also able to connect with an already running instance of CST by using a process ID on your local machine, or connect to a remote machine using a TCP protocol. Then you also have other methods. For instance, you are able to create a new or connect to any running instance of CST automatically. With the design environment class, you are also able to control the interactivity of the CST frontend, which means that you are able to block inputs, for instance, from a user while the script is running. And this can be useful to make sure that the user doesn't click on anything that will lead to an unintended result while running a script. Next, let's look at the project class. And from the project class, you will have access to the model 3D class. And this is the class you will use to control a 3D project, such as a microwave studio project, as illustrated here. Then from this class, you will also see that you have a number of methods to use and interact with your microwave studio project, for instance. And some are written in Pascal case, and some are written in Snake case. And why is this important? Well, it comes down to documentation. And when a method is written in Pascal's case, you will be able to find the documentation under Visual Basic. And when a method is written with Snake case, you will be able to know that you will find the documentation under Python instead. And since we are using the Model 3D class, we will also know that it will be under 3D simulation VBA when it comes to the Pascal case methods. Then from the project class, you will also have access to the schematic class. And the same thing applies here. To the schematic class is used to control your design studio projects, and it will have some methods that are written in Pascal case and some written in Snake case. And you will find the documentation for each method according to the method I mentioned earlier. So you'll find the Pascal case methods under the Visual Basic section and the Snake case under Python. So if we take the method net as an example and would like to find the documentation to see how to use the method. So we know it's written in Pascal case, so we look under Visual Basic, and we are currently using the schematic class, so we look under Circuit and Systems VBA. Then since creating a net in your schematic project would be a component or modeling operations, so we expand component/modeling, and we can see that we find the documentation for the net method. Then you can of course also use the search function, but when doing so I would advise you to use the search functionality to reduce the number of hits significantly. So as you can see in this example, I was able to get only 2 search hits by simply using these filters. And now we will talk about workflow. And this slide is an overview of a typical simulation project and all the steps you will need to complete in your simulation project. So you need to define your structure and select units, define background materials, and select the frequency range and so on. Then you also need to select the solver and set up the solver. Select the data you would like to record using monitors and probes, and define excitation and mesh. Then run the simulation and then analyze results and do some post-processing. And with this slide, I just want to highlight that you have automation capabilities throughout your full simulation workflow, But this does not mean that I think that you should use automation and scripting in all these steps. But if you have recurring repetitive tasks in your simulation projects, you might be able to work more efficiently by utilizing automation and scripting. When using scripting with a 3D project, such as a Microwave Studio project, it is likely that you will be using the method add to history. And this method is used to pass strings written in Python and pass them to the history list inside of CST. And these strings are written with a VBA syntax, and as you can see here, the same syntax is used in Python and as in the history list inside of CST. So here we have an example where I'm using the history list while developing my script. So in this example, I would like to hollow out all the vias on this PCB, and this will require some entries to the history list since it's a modeling step. And to know what VBA syntax I would need to create my Python script, I can simply perform operations manually inside of CST and then open the history list to see the VBA syntax that I would need to use, for instance, as in this example, create a vacuum cylinder. So now I'm able to copy this code from the history list and paste it into my Python script. And by doing this, I am able to then use the F formatting of strings in Python and then use variables in Python instead of using fixed numbers when creating my multi-line string. So as we can see here, I created a function where I'm able to use variables and then create the VBA syntax with the function that I would need later on in my automation process. So then I just create a control loop which uses my function, and I'm able to quickly go through and create all the VBA syntax that I would need to complete the hollowing of the vias that I'm trying to do here with this example. So you can see that I created a simple user interface with Python, and I'm able to specify the radius of the hole and then select all the vias that I would like to hollow out, and now could quickly hollow out all the vias. And it is not likely that you would save any time by developing this script and use it only one time. But for instance, if something similar to this would be something reoccurring across projects you are working with, then it could be the case that considering creating some automation and with scripting could save you some time later on. And now I will go through the live example where I'll be using the Python interface from start to finish to set up my simulation, model a simple dipole antenna, run the solvers, and then access results. And the point of this demonstration is not to convince you that you should use automation in this way and in such a simple case. I'm simply using this example to be able to demonstrate some automation capabilities in all or a couple of parts of a simulation project. In this example, I will be using a notebook or a Jupyter Lab running in my browser. And in the first cell, you can see the command that you would use to install the CST Python API to your custom Python installation. So for instance, if I run it in my notebook, I would run this line, and we can see by specifying the path to the CST installation and path to the wheel package, we can see that I'm able to install the package to my custom Python installation. But I already have it had the installation done, so it says so when running this cell. And next, we simply import the CST.interface module, and then also standard Python module OS. And Then I also created some variables outside of this notebook in a different Python file, just to make this example cleaner. We will get into that more about that later. And now I can simply use the CS.interface module to access the design environment class, and then use that connect to any or new method to create a new instance of the front end or the design environment of CST, and connect my design environment class, which I create here, to a running instance of CST. So I didn't have a running instance, so we automatically create a new one. And as we can see, we also get a pop-up which tells us that we are in quiet mode or scripting mode. And this essentially blocks us from interact with the front end. So for instance, if I try to click on the project template, we can see that I'm not able to click on that in the front end. And to switch to interactive mode, you can simply click on the button switch to interactive mode, or you can apply the mode in Python as well, as I will be do in this example. So here we can see that I'm using the project environment class that I created, or object, and use the set quiet mode to false in this cell. And then I'm also using the design environment object to create a new microwave studio project, which returns an object of the project class. So if I run this cell, we can see that we have created a new microwave studio project untitled 0. And now we're able to use the project class to access Model 3D and interact with our Microwave Studio project. So here I'm simply turning off the grid of our drawing plane. And next, I'm simply specifying the location where I would like to store this CST project, and then save the project using the project class. And when doing so, we can see that we see the changes immediately in CST. So now the file is called dipole antenna, for instance. And next, I'm simply creating some folders inside of our simulation project, which I will be using to store some images and export the 3D data later on in this example. And here we have the first instance of using some VBA syntax. So now here I'm setting the units and the frequency range of our simulation project. And I'm able to use the add to history list method to get settings to our history list. If I run this cell and open the history list, we can see that the name of this block entry in the history list is according to the name specified in Python. And if I double click and open this, we can see that the content is also as specified in our Python project or Python file. And of course, we can also apply other settings, for instance, set the background material or the background properties. And here I'm using the variable that I created outside of this notebook to make things a little bit more clean. But if I run this cell, we can see that I was able to set up other settings to our simulation project. So for instance, here I'm setting the boundary conditions using some symmetries, and I'm also specifying some monitors to record the data from our simulation, and also specifying the solver settings. Then you also have some settings that would not appear in the history list. For instance, when creating a new parameter inside of CST and working with the parameter list, those entries would typically not be visible in the history list, and then we're able to use native Python directly to specify, for instance, the parameters. So here I'm creating 4 parameters and specifying the value and the name, and also a description of the parameter. And then in this print statement, I'm then querying or getting a value of a parameter that I have already created. So if I run this cell, we can see that I was able to create the parameters and have them in my parameter list inside of CST. And I was also able to get the value of the parameter L that we created in the line above. And in this way, you can keep it organized, so you don't need to have variables defined in Python and simply store them in CST. You can actually store a parameter inside of CST and then get the value of it later on in your Python code. And this makes sure that you have the variable inside of Python and CST synchronized, so you don't have a different value when you're running your script and get some unexpected results from that. And next, we will starting with modeling our antenna. So here I'm simply creating a cylinder, and I'm also able to use the parameters that I defined in the cell above. So if I run this cell, we can see that I have created my cylinder, and I can perform other tasks such as transformations of this particular cylinder. So we named it the component dipole, and the solid was named wire 1. So we simply specify the name of the component and do the transformation using our parameters. And next, I'm simply, as earlier, I'm simply using a variable that I defined in a Python file outside of this notebook to complete the full dipole antenna. So if we go to history list and then modeling, we can see that we have all the other VBA entries that I would use or would need to create the dipole. If I now select a couple of entries in the navigation tree, we can see that we could specify a new material. We could also create a port for excitation of our antenna, and also we have also specified or created some monitors to record data during simulation. So we are now ready to run the solver. If I run this cell, we can see that I'm running the solver, and we can also see that we are currently waiting for the solver to complete. So when completed, we will run the next line, which selects the boundary results of the S parameters. And you also have, instead of using run solver, you also have a method called start solver. And the difference between these two is that run solver will be run in a blocking manner, which means that we didn't run the next line of code in Python, but by using start solver instead, then you would actually start the solver in CST and then proceed and running other Python operations or other parts of your Python script while running the simulation. So now we have our results. So simply save the results. And in the next part, we will be using the cst.results module. And this is simply to highlight that you can access your 0D and 1D results from your simulation project without using a front end, and by extension, a front end license in CST. So if I use the project class and close the project, and then close the front end of CST, and now import the results module, and then create a project file object and specify the location of the our CST project file. So if I run that, we can see that I'm now able to get, for instance, the result from our 3D simulation. So if I create a reference to a 3D and then use 3 items, we can see that we can have access to all our 1D results or 0D results from our simulation project. So here, for instance, we have the path to our S parameters. So to get a particular result loaded into Python, we simply use the get result item method and specify the path to that particular result. So in this case, I'm using the S parameters again. So now we created an object of which is attached to this result. And we can query all the attributes or methods that we have with this object. So we can see that we can get the data, we can get the parameter combination that corresponds to the simulation that yielded this data, and we can also see the run ID. So for instance, if you would use a parameter sweep in your simulation, you can also see which iteration or which sweep the results correspond to. So we see that I could get the parameter combination and also see the label of the x-axis of this particular result. And if we now read the data of the S parameters, we can see that we get it as real values for the frequency components, and we get the complex values of the S parameter data, and then we also see the complex value of the import impedance of our lumped element or of our port in the simulation project. And this format is compliant with the NumPy, so we can easily convert the data into a NumPy array. So if I run this cell, we can see that we get it in the correct format immediately. And now we are ready to use NumPy to do some post-processing. So here I'm simply converting the data to dB instead of have it in complex numbers. So I do the conversion and simply plot the data. And now we can see that we have the same result as we saw in our CST project. And next, after you're done some post-processing and would like to have the results stored together with your CST project, you're also able to import your results into your simulation project. But when doing so, you would need to have a front end active or a CST instance active. So if I run this cell, we will see that I get an error. And that is simply because we are no longer attached to the project class is no longer attached to our CST project. As we recall, I closed the project and the design environment earlier. So to get the results into our CST project, we simply use the design environment class again and create a new instance of a CST frontend. And we then connect and open our project file. And if I run the same code that didn't work earlier, now when we have project class connected to our simulation project in CST, we can see that I was able to import the results to our simulation project. So here we can see that we have it still in the format, so we can view it in linear, dB, and in complex values. If I save this, and in the next part of the example, this live example, we will have a look at the schematic of our project or design studio part of this simulation project. And now we will switch and be using the schematic class instead, which correspond to working with the schematic part of the project. So here I'm simply creating a block, and I'm specifying the name as L1, and it will be inductor, and I can specify the properties of the inductor and the units of the inductor. So you can see by running the cell, I simply created the inductor and placed it in our schematic, and we can see that it also was able to apply the settings. And next, I will be using a function that I created to make it a little bit more readable. But here I'm simply specifying the name of the next block that I will use in my schematic. And it will be a capacitor I specify the position and some properties of the capacitor, and then I'm doing the same thing for a ground block. If I run this cell, we can see that I now have my capacitor and my ground block as well. And of course, I can also create external ports. So for instance, by running this cell, we can see in a similar way, I can now create the port in the simulation project. And next, to complete our min-match circuit, which will be attached to our antenna, I would like to create the net that connects all the components. There, I'm simply using a nested list and specifying if it is a external port, for instance, or a block. So as an example, we have the block called C1. If we look at the navigation tree, it corresponds to our capacitor, and would like to have the connection indexed 1 connecting with the inductor with the connection point 0, which would correspond to this termination point and this point in the schematic. And in a similar way, we would like to connect the inductor to our microwave studio block or our antenna containing the 3D simulation data. If I run this cell, we can see that I now have my circuit or define my nets, which connects all the components. And we're now ready to define our simulation task, which can also be done through Python. If I run this cell, we can see that I simply creating a simulation task. It will be a S parameter task, and I specify the name and set some properties of this simulation task. If I go to task, we can see that we have our S parameter task. And next, I will create a combine results task. And as you can see, we're still using the same reference to the schematic.simulation task, but we are using a different type, but there's still the same, we're still using the same method set property. And this is an example where it would be nice to be able to find information about this particular method quickly in the documentation. So we know it's under automation and scripting. It was written in Pascal case, so we know it's under Visual Basic. We are in the schematic, so it's circuit and systems, simulation, and simulation task. Here we can see that we find the method set property, and we can see how we use it for all different simulation tasks that we can define in the schematic project. If I run this cell, we can see that I now have my AC combine results task, and we also specified all the settings we need through Python. And next, since the last task that we created was the AC combine results task, running this method update will actually correspond to selecting or right-clicking on a simulation task in your simulation project, and then clicking update to only update that particular simulation task. So if I run this cell, we can see that I have updated the combine results task, and we have our results. And to then update another simulation task that we have already defined, so in this case the S parameter task, we simply first specify the name of that task and then run update, which would correspond to selecting and right-click on another simulation task inside of CST. If I run this cell, we can see that we now have our S parameter task. But of course, you can also update all the tasks or simulation task in one line. So then you simply use the project.schematic.update results, which would correspond to using this update button under the home tab, which updates all the simulation tasks that you have defined. And next, for demonstration, I would like to get the results from our simulation tasks without using the cst.results module. So this can be done directly either through model 3D class, which would correspond to getting the results from your 3D simulation, or schematic, as in this case, to get the results from the simulation tasks. So if I run this cell, we can see that I can navigate through the navigation tree inside of CST. So we can see get first child name corresponds to the first child name under the tasks folder in the navigation tree. And then by using the same name again and get the next item, we can see that we iterate and get to our next entry in the navigation tree. And using this recursively, we can simply navigate to, for instance, our S parameter results data. There are also other functions that you can use to have some filtering and get all the 1D results, for instance, using Python, and you can find more about that in the online help. So now we have the path to our S11 or S parameters result, and we also have the run IDs. So by simply using the path and the run ID that we are interested in, so in this case, the run ID is 0, we can read the data and get it to Python. If I run this cell and then use my S11 underscore schematic object, we can see that I can use the method getArray in X and getArray in Y. And in the case of Y, I'm using attribute magnitude, which corresponds to getting the results directly in the format as of viewing it in a linear scale inside of CST. So if I run this cell, we can see that we get the data similarly as before, and we can easily convert it to NumPy arrays also as before. And here I'm simply converting the data into dB scale and plotting the results. And we can see that we have the same data in Python. And next, if we'd like to export 3D data from our 3D simulation, we can do that by simply first selecting the view, the plotting view of our 3D data, and then use ASCII export to export the data. And in this case, we will be exporting the data in the HDF5 format, and later on we will use the H5Py module to read the data. And here it is the case that you will export the data in the same format as you are viewing it inside of CST. So it is important to set the plot settings before doing your export. So here I'm doing it using VBA syntax, but you can also use some native Python codes to apply these settings. But this is simply to demonstrate that if there is some functionality that is missing or that you would like to use that is present in VBA, you can, instead of using add to history list, you can also use the method execute VBA code, which allows you to run this piece of VBA syntax directly from Python. If I run this cell, we can see that I'm able to load and set the plot view of our 3D data of the electric field. And in this case, we're using the results from our AC combined results simulation task. And then I simply specify, in this case, a fixed numbers of steps to set the resolution of the data and set a stub volume where I would like to export the data from. And then, of course, we can also use an ASCII format to export the same type of data. And we can also use a CSV format. And note that I'm using a smaller step size to have a lower resolution of the data in these cases. And if I now open the project directory, go to export and data, which is the folder that I created at the beginning of this example, we can see that we have the exported data here in the 3 different formats. We can also see that the HDF5 format is a little bit more memory efficient, because even though we used a lower resolution for the ASCII format and the CSV file, we can see that it's still about the same size. So if I now open the ASCII file, for instance, we can see that we get the data with the X, Y, and Z coordinates of all data points, and we also get the electric field components in X, Y, and Z in real and imaginary parts. So next, we would like to read the data in the HDF5 format by using the H5Py module that comes with the bundled Python installation. If I run this cell, where I simply viewing what type of data sets we have, we see that we have the electric field, we have the size of the data, and we also have the X, Y, and Z components in real and imaginary parts. And then, of course, we also have the positions as separate data sets. So we have the mesh line coordinates in X, Y, and Z. So here I'm simply reading the data by using the H5Py module, and I'm accessing the data and plotting it in a contour plot, which would correspond to viewing the max field plot setting and the X component in CST. So if I run this cell and plot it using matplotlib, we can see that we get the results of the X component, and this would correspond to applying these plot setting inside of CST. So we see that we have the X component and the maximum. And now we are done with our simulation project, we can move on with another example. So if we go to the Home tab and under the Python button that I talked about earlier, and then under Run Scripts, we can see that I've created a Generate Report folder and a report generation script. So if I click on that, we can see that by using Python and blocking interactions while running the script, I can easily, for instance, create a template of to use as a report of our simulation. So if I update this contents page, we can see that we have some content. We can see that we could automatically attach images from our simulation project and also attach some simulation metadata from our simulation as well into our report. So this is just a crude example, but just for some inspiration, for instance. And you can see that you also have material data as well. So in conclusion, you have automation capabilities throughout the entire simulation workflow. And my advice would be to identify recurring and repetitive steps across your simulation projects and consider creating a custom solution by utilizing scripting to incorporate some automation in your workflow. And then, as I mentioned a couple of times, recall the snake case and Pascal case for efficient navigation of the documentation. And if you're interested of seeing more examples of using the Python interface, we have a Python blog on our TECHNIA webpage, where you'll also be able to find some tutorials and examples. And then starting from next year, we will also be providing some introductory courses by using Python and the Python interface with CST. And then we also have the knowledge base article that I referred to earlier and the QA number if you didn't catch that before. So thank you for listening and thanks for joining this webinar today. And if you have any questions, just reach out and I'll try to answer them for you. And I hope you find something useful from this webinar. And that concludes my presentation, and have a nice day.